Colleagues, we are at the top of the hour. Very welcome to our session today, focusing on waste management, a sub-community of practice that we run at ASLM through LabCoP. My name is Francis Ochen from the African Society for Laboratory Medicine, and I am your moderator today. We will take 2 presentations with questions and answers within the next 1 hour. Please join the discussions through the chat. We do have language interpretation services like we've indicated in the slides that came just before this. And please keep to either English, French, or Portuguese channels, depending on your preferred language. One development that we have to bring forward is that we will, going forward, probably starting next week or the next eco session that we'll be having, we will be issuing accredited CPD points to participants as well as our facilitators. And all you need to do is to attend at least 45 minutes of our session, and then you will be applying to redeem your CPD points through the links that we'll be sharing in the chat towards the end of every session, every other time that we run a session. The CPD points will then be awarded within 5 to 7 days from the day of your application. Kindly note that when you apply for those CPD points, we will also still do some verifications based on your attendance with the records that we will be getting from our Zoom analytics. This does not replace the certificates that we've been issuing, and you can still ask for your certificates and you will get them through the normal channels that we've been following. Back to our session. Today we will be handling waste management with a special focus on management of spent Xpert cartridges. We know that the GeneXpert system is a widely used molecular diagnostic platform that was developed by CFID and has really revolutionized lab diagnostic landscape with speed, accuracy, automation, and accessibility. The system is designed to be user-friendly and can be deployed in a variety of settings, from high-tech laboratories to resource-limited clinics in remote locations. This success, however, comes with the inevitable challenge of having spent or used cartridges in locations where in-house capacity for safe and reliable handling and final disposal may be lacking. And so in today's session, we share the latest information and bulletin on GeneXpert products. We will also review occupational and environmental risks, considering the unique design and use of Xpert cartridges. And then finally, we'll be also reviewing treatment options and potentials for holistic waste management related to the spent cartridges. And to take us through this, we have 2 presenters. Our distinguished presenters today are Edward Chrysiunas, and Edward is the president for West Not, Want Not, the popular WNWN. Shall I call it double WN? And then the second presenter will be Rumbi Zai Ndugwani, and Rumbi is a public health programs manager for Europe, Middle East, and Africa at CFID. So colleagues, let me hand it over to Ed to start it off, and then we'll end with Rumbi and go into the questions and answers. Ed, over to you.
Merci, sir. Let me get my screen up here. Good. Display settings. Super. Thank you. Thank you so much. Jumbo, bonjour, bon dia, salbana, salam alaikum. I saw someone wanting us to translate into Arabic. It is again once a pleasure to be here this morning with our colleagues from ASLM. Thank you very much, Francis and team, for inviting us. Also a thank you to Cefiat and Rumbi and the Cefiat team for reaching out to us. We're not strangers to Cefiat. We have been researching and working with them for a very long time. My colleagues know I even have a Cefiat cartridge on my desk, okay? Because we've researched this waste stream for a very long time. While I am presenting today, my colleague, Victor Istov, is also listening in, and he'll be available to answer questions. He and I collaborated on this PowerPoint. One last item before I begin, I would actually like to just send our thoughts and prayers to our colleagues in Kenya who are dealing with the devastating floods. And I know the same thing had happened recently in Malawi. So actually anywhere in the continent or in the world where we're being devastated by water, by rain, by climate change, it's obviously our thoughts are with our colleagues there. Okay, so we are starting off today, as Francis has indicated, cartridge waste management in viral load testing, the mouse in the room. And I thought it was very apropos. Again, we've been dealing with viral load waste management for 5 years. And it dawned upon me of the volumes of liquid waste are pretty tremendous. It's like the size of the elephant. That's a picture actually I had taken in Eswatini some years ago. And then I took a small cartridge. I took the GeneXpert cartridge and I put it in my hand, and I thought, God, it's the size of a mouse. It's tiny. Okay. Wow. And we know there's a lot of them. We know the pros and cons. We've been discussing the pros and cons of these two waste streams, and they're not just the only waste streams, ladies and gentlemen. We know that there's others, but and you'll see during the presentation, I'll discuss that a bit. So what are our objectives today? Discuss Cepheid cartridge waste management. We're going to go over the risks associated with the cartridge waste management, and we're also going to discuss some strategies and options on cartridge treatment. Now, as many of you know, this is not the first time I've presented. We are actually part of a larger team. Our fantastic colleagues from ASLM, I think you know many of them, Colin, Danafi, Beatrice, Adisu, you know, Pascal has moved on, but still was been part of our team. Our CDC colleagues, Dave Bressler, Monte, Katrina Sleeman, Clement, then myself, Rick Morgan, our resident chemist, Victor, and Boba. So we have actually been working, collaborating on this and looking at these waste streams and in communication with all of you for several years now, and getting your feedback and understanding some of the challenges and realities. I was doing a lab audit yesterday at a local university, and coming across one room, I noticed this, and I took a picture of it, from Nelson Mandela. I never lose. I either win or learn. I would tell you our experiences in the past several years have really led us to learning a lot, and the learning continues. We are moving away from poor waste management practice. We are improving things. So to a certain extent, we're winning or we're learning. As many of you probably know, what has been the basis and the interest of dealing with the viral load liquid waste? And the big concern has always been with the guanidine isothiocyanate. And it is in the literature that shows that if you were to mix any acids or bleach with this liquid, that you will generate hydrogen cyanide gas. In fact, our chemist, Rick Morgan, did even perform this in the chemical fume hood when we were initially researching this. This is going back 4 years ago, and we actually created hydrogen cyanide gas. In our review of the literature, we've actually been hard pressed to find any accidents or injuries or near misses associated with this. That doesn't mean they haven't happened. Absence of evidence doesn't mean evidence of absence. So we know that this risk is out there, and this does play a part in part of our discussion today. You know, as I mentioned at the beginning of the presentation, it's not just about a liquid waste or a cartridge waste. In fact, this diagram came together in our discussions with Riders for Health. I think some of you are familiar with the group that is involved in transporting specimens from potentially remote areas back to either a point of care testing facility or a centralized area. And there's a lot of steps involved in that. So while we're only focusing on the cartridge materials today, there really are a lot of other items that are being generated. In fact, it's quite a puzzle. And these are photographs from throughout Africa that we've seen. And again, these challenges are out there. We are working, when I say we, ASLM, WN International, and CDC on an updated laboratory waste guidance document that does provide more guidance on the treatment of these waste streams. So look forward to sharing that in the coming months. So, as Francis has indicated, the evolutionary process of Cepheid, as well as all types of point of care testing, has been incredible. In fact, that more and more testing can be done very close to where a patient lives, allows for faster turnaround time, diagnosis, and eventual treatment. So there's no lack of cartridges and other items. Again, it's not just Cepheid that we should be concerned about. There could be other items as well. In fact, in Lab on a Chip, and I had presented this at ASLM Cape Town. This is written by a number of our colleagues, including Colin Doteno and Pascal, but also Alice Street, who's a researcher in Scotland. And they actually were looking at the number of point of care diagnostics in single-use microfluidic devices. And the numbers are really astounding. Just look at these number of tests that were done with COVID, over 1 billion. And now we have malaria and HIV. So this is clearly an item to be reckoned with, not just in Africa, but around the world. So you are utilizing the same things that many countries, low, middle, and high-income countries, are using to diagnose infectious diseases. But this gets us to our yin and the yang, which we have previously used as well. And in this particular case, I show the elephant. And we often say, the elephant in the room. That is a mouse in the middle. That is a mouse in a trap that I had. It's small. It's about the size of the cartridge that you see. So we know that the large amount of liquids are challenging, but we also have issues with the cartridges. And the additional challenge with the cartridge is not so much the liquid. I mean, it is a risk, but now we have a plastic component, and we have a small plastic component to deal with. So let's talk about those, identifying the hazards. What are the risks, the controls, and reviewing the controls. You know that there's physical, biological, chemical, and environmental issues. In this slide, what I really would like you to focus on is this area right here, where in fact you can see we're looking at the volume of liquid in the cartridge. How much does it actually weigh? And how much waste would there be per test done? In this particular slide, you're seeing, and this is actually some of our early experimentation, was the collection of GTC liquid. Those are 20-liter containers. So they're going to weigh about 20 kilos. This was actually taken to a cement kiln in Zambia, in Chilanga, and this is how we dispose of them. On the right side, you see these cartridges. Remember, as you recall, these things actually don't weigh very much. In fact, one of the things that Victor worked on was, again, we collected a lot of data from 9 countries related to weight and volume of waste. In Kenya, we calculated there were 35,000 liters of liquid waste with GTC that was generated in 2019. That's enough to fill this squash cart to one height of liquid, just thinking about the flooding that's taking place now. If we actually looked at the solid waste, on the right side, we estimated 200 tons of solid waste. And this would be the equivalent of filling up an American football pitch with waste that's extremely to about 6.5 meters. So we started to look at a couple of things related to, one, the volume of liquid in the cartridges, and then their particular weight. Here's an interesting site and interesting perspective. When you receive the cartridges, at least when we were receiving the cartridges, it came with a compact disc, which actually has information about the composition of each of the cartridges. And we weighed the cartridges, and it actually 2,000 Xpert cartridges would have approximately 20 liters of fluid. 2,000. So that's a lot of cartridges. The issue so much isn't the liquid as much as what do you do with, or how do you manage 2,000 cartridges if you had 2,000 cartridges in one location? Because we know using this as a point of care device, you probably won't have 2,000. However, if they are brought to a central collection area, you can reach that number and higher. And you'll see we have one case study where that in fact occurred. And this is just pointing out the data that's information. Again, this is in the product CD provided with the Xpert cartridges, and points to the amount of material that's located in each of the cartridges. So you really see it's a very, very small amount of liquid. Even the lysing reagent, the guanidine thiocyanate, is only 2 mLs per cartridge. See this again in this other type of cartridge as well. Not really that much in the way of liquid. Now, what has been interesting, what has transpired, and we know that this is actually going on with a number of companies of looking at the impact of guanidine thiocyanate, the volumes of liquid. And in fact, some of the other vendors have reduced their chemistries, although the concentration of GTC may have gone up. In the case of GeneXpert in their qualitative test, this is actually presented a poster presentation in 2023. They replaced it with a safer lysing agent. So again, that has an impact on the environment, but we still have to get rid of the cartridge. So while we've addressed the issue of the liquid, we haven't really answered the issue with the cartridge. So we've actually looked at these cartridges, we've dissected them. That's a cross section you can see on the bottom left of what it looks like. Fantastic design, really, from a biomedical engineering, fantastic. But what's really interesting, once you've added your sample to the container, in fact, if you flip this container upside down, there isn't any liquid that comes out of it. At least we've not experienced that. You add your sample to the cartridge, you snap the lid on, and you put it into the unit to be processed. And that's it. There's no exposure of a staff member to any particular liquid because of the design of how it's manufactured. So what we have is a product that's low in weight, it's a low volume of liquid, sealed to prevent exposure. We haven't actually done any studies to look at the inactivation of infectious agents. Again, Cepheid, and this is, I think, Rumbi will talk about in her presentation in a publication, their most recent publication on how the contents of the cartridges. So I will leave that to her for any questions to be answered. One of the things that we also find interesting, because the cartridge itself is made out of polypropylene, so we've analyzed the plastic components here. We're not as concerned about dioxins being formed during incineration. Now, again, it's still a plastic. If it's not incinerated at the appropriate temperature, you will have black smoke. So the plastic, regardless of whether it has halogens or not, if you're not operating your incinerator properly, you will have poor combustion, which is an identifier by the black smoke that would be coming out. So key treatment issues. We're looking at the logistics of, and we've kind of lumped a couple of things in here, but the issue with GTC liquid waste was its transportation. The same thing carries over to the cartridge. On the liquid, large volumes of liquid. On the cartridge side, as I said just a few minutes ago, you have the issue of a point of care facility. You may only have 4 or 5 tests a day, but if you are using larger units, you could have hundreds of cartridges a day. So now we start having a storage issue. And of course, we get into the issue of how to dispose of liquid, but then the issue of the cartridges. A liquid material, large volumes, a solid material, large volumes. We actually did some experimentation to look at what might be methodologies that could be used. And in fact, in this case, I had gotten a couple of boxes of the cartridges. This is a commercial autoclave unit. I actually processed the cartridges in a sharps container, went through a cycle of 45 minutes at 140 degrees centigrade. In fact, the cartridges don't melt. They are a very, very robust cartridge. So in this case, nothing happens to the cartridge. They're not destroyed. Conversely, there's a company called Tessalus in France that actually did do some work with Cepheid's GeneXpert Cartridge to look at the reduction in size and volume. And we did 2 things here. Well, actually say they did one thing, but I also did some additional testing. So in this particular case, this is a autoclave that shreds material and actually gets you very small particle size. So what I ended up doing is taking Cepheid cartridges, putting them into the sharps container, and what you see on the bottom left are the particles that are left over from the process. On the right side here, this liquid container, we actually captured all the condensate that was coming from the process. And in fact, what we found is the concentration of the cyanide in the unprocessed liquid was 25,000 parts per million. In the processed cartridge, it was 20 parts per million. Now, we don't believe that we destroyed the cyanide. We actually were diluting it. Now, in some jurisdictions, dilution would not be considered a way of managing material. However, we know that's been the practice for many years. In fact, this does reduce that concentration, so making it less unsafe. I'm not going to say it's safer, but it is something to potentially consider because you do have an incredible amount of dilution here. One thing as well, which may not be very practical, although this has been a recommendation for WHO for management of chemicals and pharmaceutical waste, is in fact encapsulation. So I did try an encapsulation method. I made up some cement, I put cartridges into this plastic bag, and I poured cement on. Note that I didn't have any aggregate in the cement. And in fact, what you end up having is floating cartridges. So, okay, let's try this again. And next time, I did add some aggregate, and this is a small number of cartridges, added cement to it, let it sit for 2 days, and I broke it open. So maybe not a practical method, but again, if the number of cartridges are small and someone was considering encapsulation, it is something that can be done. The cartridges themselves, being plastic, are going to remain intact. Anything that's inside of the cartridges will stay there. Now, as incineration has been a very common technology used in a number of low and middle income countries, we did have the ability to do some testing on a pyrolysis unit. So on the left, you see the cartridges being added to the pyrolysis unit, temperatures of approximately 800 to 900 C were in the pyrolytic unit. On the right side, in fact, what you see is the end product. This is the ash. And in fact, we tested the ash and found no guanidine thiocyanate or thiocyanate present. What we weren't able to do was actually test the air filtration system. We're hoping to do that in the future, but you definitely get volume reduction and destruction of a material, at least in this particular process. Now, we know many incinerators have been utilized, and we've seen many of them around the country, or I should say around the continent. I think the challenge for us is incineration versus incineration. And what do I mean by that? I think you can quickly surmise some of the photographs here are basically probably not appropriate devices for destruction of material. They're lacking any controlled environments. They're lacking, in some cases, a fuel source other than the waste itself. Conversely, the unit on the top right, that is actually an incinerator in the city of Windhoek that has air pollution control, a ram feeding device. What you see below is a little bit of improved incineration processes, but also still have some challenges and issues related to operation of them. In fact, the next couple of slides I think are really revealing, because this is actually a case study that took place in South Sudan. So a few years ago, they were working with Abbott platforms and 40 GeneXpert platforms around the country. And they actually had collected 17,000 GeneXpert cartridges. Now, they did obtain an incinerator. And this particular unit on the left side here, this is a ram feed device. So in fact, the top door here is not being open to place materials in, which actually has an impact on temperature. Rather, it has this device, which is automatically operated. Waste is introduced here. This guillotine door opens up, waste is pushed in. So now you have more temperatures that are more consistent for the proper combustion of the material. You're less likely to see black smoke. Still are some challenges and issues. And in fact, they did respond to us with some recommendations and lessons learned. And I think this is a really key thing here. You know, waste management is an incinerator isn't the solution for everything, especially if it's not operating correctly. And in fact, they had some issues with commissioning of the unit, and it ended up that through a collaboration with a team from Zambia, they were able to get their unit up and running. So critical things in the process: equipment operation and routine maintenance, a waste management register. What do they mean by that? Keeping track of the waste that you're receiving. You can't manage what you don't measure. That's the reason for having a waste scale. Waste transportation, as I mentioned earlier, utilizing a service, something like Riders for Health, or even reverse logistics for transportation of material. If drugs or essential medicines are being transported out, familiar with that in Tanzania and Ethiopia. So is it a potential to utilize that type of surface when you might have cartridges or smaller volumes of waste? Obviously, ensuring your staff are wearing personal protective equipment by the operators as well as the waste handlers. Critical as well, this is a sophisticated piece of equipment, at least the unit that was utilized or procured in Juba. It's fully automated. You have to have a skilled workforce that understands how to maintain it. And that is very critical, even considering a service maintenance contract. Very, very important. Next, the key recommendations: install a chimney of the incinerator with the appropriate height, train local service providers, again, maintenance and repairs, build capacity, ensure that you are training a number of people to operate the unit, and have periodic visits, even exchange visits. In Zambia, they had installed a number of incinerators a few years ago, and there was a follow-up with the incinerator operators by one of the vendors to ensure that things were working properly. Ensure regular audits and documentation. Again, maintenance, maintenance, maintenance. Developing a waste management plan so you actually understand the flow process from the points of generation during transportation and collection. One additional thing is they recommended job aids and posters for waste handlers and the personnel operating the equipment. So the key issues here, and I bolded a couple of things related to the cartridges because I think this is it. The logistics of transporting these things, if you cannot manage them at a local installation. Again, Victor and I had done some work in another country in the Republic of Georgia that in fact Victor visited a couple of small clinics. They only did 3 or 4 tests a day. Yet that facility had an incinerator on site and they waited to accumulate their materials before they were going to incinerate them. The challenge was the incinerator wasn't being maintained properly. So there were some issues and challenges with emissions. The other issue too is the storage of the large volume of waste that's being proposed. Now remember, what was generated in Juba was collected over a period of time. Materials are still being collected, but they now have a system in place. They also have an incinerator that is functioning properly. I don't believe they've done any emission testing, but they've certainly utilized the RAM feed, which is going to have a positive impact on the temperature controls in those in that incinerator, I should say. So what are the options that you can have with the cartridges? Certainly incineration locally. Cement plants are still an opportunity. The issue might be they might be looking for a critical mass. The pictures that I showed you previously from Chalanga, again, those were 20 liters of liquids. Now, how many cartridges would, what would the containment system look like or collection system look for those cartridges to take to the cement plant would be dependent on how they would be loaded into the unit. Pyrolytic process is obviously an opportunity. Transboundary movement, although this could be costly transporting it to, example, if you're in the surrounding area of South Africa, like Eswatini, Mozambique, or Zimbabwe, if they were going to manage that material. Autoclaving is still something on the table. Of course, the issue there is either the destruction and the concentration of the GTC that could still be remaining. Lastly, is the encapsulation is an option for very, very small volumes if that was something to be considered. This might be able to be coupled if you are having to deal with any pharmaceutical waste. We have been seeing an increase, in fact, in a few countries of chemotherapeutic materials, and that is another way of dealing with those particular waste streams as well. So as I'm near the end of the presentation, remember, there are a lot of components to the healthcare waste management stream. It's not just the cartridge and the liquids that we are dealing with. You might have actually additional specimen tubes, swabs, pipette tips, etc., things that need to be utilized and properly disposed of. So really take a look at the entire picture. I think the recommendations from Juba are extremely helpful because that was an actual case and a challenge that they faced. And with that, I want to thank you very much. Yabonga, asante sana, merci beaucoup, obrigado, sukon. Thank you.
Thank you very much, Ed. Fascinating with really clear details brought to the surface and options for considerations when it comes to handling spent cartridges. Colleagues, keep your questions or comments coming through the chat. Let me now turn it over to Rumbi to take us through the next segment of these presentations, and then we'll come back to deal with those questions and comments. Rumbi, over to you.
Thanks, Francis. I'm trying to upload my slide. Okay, I think you can see them from your end now.
Yes.
Okay. Once again, good afternoon, everyone. Like Francis said, my name is Rumbi Ndungwani. I work for Xpert as the Public Health Programs Manager. I would like to also thank Ed for the presentation and going before. I think he has covered the bulk of the things that I'm going to talk about and great suggestions and recommendations as to how countries can effectively manage waste. My topic today will be on the disposal of Xpert test cartridges, but specifically I'm going to talk about the waste management bulletin that Xpert recently updated. So my outline will be as follows. We'll talk about the bulletin, why it was developed, and then we'll talk about which cartridges contain GTC and what are the associated risks. And we'll then move to the disposal of the GTC containing cartridges. I will not dwell much on this because, as you have seen from Ed's presentation, that it was properly handled. And finally, suggest some resources that country teams can actually use on the ground. So in 2023, ASLM, and I think with WN, published a LabCoP cookbook of best practices, which they were really focusing on the management of GTC from the testing labs. And one of the key highlights that were mentioned there, I think they really tried to point out that waste is not only from manufacturers, but it's also generated at every point of samples being collected and then tested until the result is given to the patient. So as we think around waste, let's not only think about the chemical waste. Ed also covered on the solid waste that is generated, and not only from manufacturers, but also from biohazard materials that we collect every day and we handle every day. So the purpose of this bulletin was inspired by the recommendations from the LabCoP cookbook, where GTC was highly mentioned. And in this bulletin, we highlight what are the cartridges that contain GTC, and we also talk about the associated risks. The second recommendation that we get from the bulletin is on how to properly manage our waste, and bulk of it is what is from the WHO and also what other countries managed to do as case studies. And finally, just how to properly dispose of solid and chemical waste. So I think, let me start by emphasizing that not all GeneXpert cartridges contain GTC. Only selected cartridges do have GTC. And as you know, Xpert started with the TB cartridge, and the TB cartridges do not contain GTC, either for the MTB Reef Ultra or the MTB XDR. There is no GTC in the TB cartridges. The cartridges that contain GTC are listed in this bulletin. I'll start with the HIV qual cartridge. Some of the countries that we work with already know that we have the qual extended coverage cartridge known as HIV-1 qual XC. This cartridge is recently received its WHO pre-qualification and does not contain GTC. Unlike the older or legacy cartridge, HIV-1 qual cartridge, which had GTC. But one thing to note that in as much as we have GTC in all these cartridges, the volume on its own is very low. And this is again coming back to the total reagent within the cartridge, which in terms of volume is also very small. And if you're looking at the amount of GTC in that cartridge, the volume ranges between 10 to 20%, and at most 30%, but in very few cartridges. So all in all, what we're trying to say is that we have very little amount of GTC within the cartridge. And the cartridges that I have listed here are for HIV-1 viral load, both the extended coverage and the old one, the hepatitis B and C, CTNG, Ebola, BCR-ABL, C. difficile, enterovirus, the flu and RSV, MRSA, and the no virus, and also the T virus cartridge. These, like I said, they do contain GTC, but the content in these cartridges is low. And as such, the waste poses a minimal risk ranging from acute toxicity in the event that one ingests the contents of the cartridge or is exposed to the contents of the cartridge, or it can cause skin to eye irritation. So as you can see that the risks that if a person is exposed are quite minimal. So which is something that we should also take note of, that yes, there's GTC, but what are the side effects or the effects should one be exposed to the GTC? In terms of handling, this follows the normal waste or biohazard handling of waste, which every lab, I think, has guidelines in place on how to properly manage biohazard waste. And in this case, remember, you are not only dealing with chemical waste, in this case, GTC, but you're also handling biohazard material. Either you're dealing with HIV, hepatitis, CTNG, whatever one of the tests that I've mentioned in the previous slide. Just bear in mind that there's still biohazard material and precautions still have to be taken care of. So like Ed mentioned as well, by the design of the GeneXpert, primary containment is already addressed. The cartridge is closed. So the vial itself offers primary containment because it's already closed. And should there be any spillage because the cartridge was not closed, then you can handle the side effects, as I mentioned. But ideally, if the cartridge is properly closed and then moving to secondary containment, where you are now separating the waste and saying, this is biohazard, I'll put it in the biohazard bag before I ship it for disposal. And then moving again to tertiary containment before you properly dispose. All of these are the stages that a lab ideally has to pay attention to, and I believe that based on the guidelines that are within your settings are already being addressed. And this goes on not only to handling and storing, but also properly labeling the biohazard bags, whether it's bio waste or chemical waste, depending on how this is going to be disposed. Like Ed mentioned, I think for plastic waste, which I think might be an area that we might want to pay attention to, depending on how you're going to dispose it, then proper labeling should be addressed in that case. Again, so if we are going to deal with GTC material and the cartridges that I have mentioned, WHO, ASLM, many organizations, including WN, have highly recommended the disposal of GTC material with temperatures above 1,000. And incineration has been one of the key methods that have been used to properly dispose GTC waste. But there are other things, other methods that have been coming in, like the cement factories that Ed also mentioned, where you find temperatures above 1,400 degrees Celsius. But whatever it is within your setting, if it's going to be incineration, then it's not every incinerator that will be able to properly destroy the GTC, because some of the incinerators do not go beyond 1,000. So again, service and maintenance contracts should be in place to ensure that these incinerators are properly maintained, and you know exactly what temperature is being utilized at that particular moment when you are destroying GTC containing waste. In some countries where these resources are not available, for example, the cement factories or the incinerators, which go beyond 1,000, other countries we have seen, and I think we're actually implementing this, are outsourcing waste management to private companies. This is an alternative source that is currently being used, a bit costly because they are funds that need to be budgeted for this to take place. But it's an alternative that countries need to put in place. But I would want to also say that from the CEFED standpoint, we do understand and appreciate that there is some inconvenience that comes with disposing of plastics and reagents which are generated by the Xpert tests. And most of the molecular tests that are in the market. But we are committed to working with countries. There are projects that are underway. There are things that we are also working on to make sure that we collaborate with countries and some of our customers to ensure that this issue, this burden that we are currently discussing today is properly handled. So it's not like we are quiet. We appreciate what is going on, and we are working with countries to make sure that some of these issues are addressed. So in terms of spillage, then I think every lab has a manual on how to make sure that should there be a spillage, should there be any contact with the GTC waste, then this is properly handled, like the flush areas with showers within the lab, soap with which you can properly wash off any material that would have been spilled or in contact with the user. Just to note that a spill from a single cartridge or a reagent vial onto a lab surface would contain a maximum of 1.5 mils, which is about 10 to 20% of the GTC volume that the person is exposed to. Again, this is just emphasizing that there is minimal amount of GTC within the cartridge, and this should be properly handled in the lab. Should a person be exposed or should surfaces contain any spillage of the GTC material. And of course, as you are handling these spillages or the contact to the material, make sure that IPC is also observed during the time the handling is being done. I would also want to say that there are alternatives to bleach because, as you know, bleach in contact with GTC also produces hydrogen cyanide. So again, we strongly do not recommend labs to use bleach in terms of when you're handling cartridges that have GTC. So this is my last slide, and as I conclude, these are public documents that are available for us to use as countries, as institutions to manage waste. And I'm sure there could be more out there, but I really found this helpful as I was going through them. The LabCoP cookbook is quite recent and contains new information. The WHO recommendation also is very good because it touches on a lot of areas that we need to pay attention to, not only about GTC, but waste management as a whole. So please visit these sites and access all these documents for your own benefit. Thank you very much, and I hand over to Francis.
Thank you. Thank you very much, Rumbi. When you pronounced the two parts of your name, I thought it was just but one. So I am not going to try to do both, and I will just call you Rumbi for now. Again, very, very exciting insights from your side and colleagues. The bulletin, the revised bulletin from CFID is a must-have document to support you, because once you know what it is that you should do or what it is that you're dealing with, becomes much easier to determine what direction you take with your actions. Again, thank you very much for the many questions that are coming through the chat. I am not going to try and summarize the session because we need to get time for the many questions that have come through. And I will start with Ed. Ed, you've rested a little, and Yes, and so this is coming in from Job Achidri, and Job is really asking a question on reverse logistics for spent cartridges or the expired ones. Would you recommend that this is the direction that most people should take in the event that they are unable to handle the safe disposal of these cartridges locally wherever they are produced? We also appreciate that there is a principle in waste management that speaks to proximity. The waste should be handled at the nearest point where they are generated, because then moving them around might also be another problem that you're going to be dealing with. But your insights into this, Ed?
Yeah, great question. You know what? Something that, in fact, we have a technical working group within ASLM looking at an updated lab waste guidance document. And we talk about treatment at the point of generation and treatment in a centralized collection area. Both are potentially applicable. It depends on, and I've traveled the roads of many countries in Africa, that infrastructure is a limiting factor here. That Riders has a motorbike. They can travel through some narrow passages that a vehicle could not. I think what I would like to see is further investigation into technologies that could be utilized at the point of generation, but taking into account the use of solar energy. That is utilized. Laboratories are using that to maintain cooling, even operating their systems. I think there's not we have said this for the past 5 years, there's no silver bullet. There's no one answer for all of this. It's basically on a case-by-case basis. I think the difference between when I started as a med tech 43 years ago, the technologies that are available are definitely better. As we have gotten good platforms for testing into the laboratories, we need to get good equipment for treating the waste into these same locations as well.
Exciting. And I think that also, Simon Peter, your question related to any work that ASLM is doing regarding guidance on how to handle GTC. Now you've heard from Ed, who is working with multiple colleagues from ASLM and other partners on developing really guidelines. And we also have other recipes, and my colleagues from the comms department should be putting a link here to some of the recipes that relate to waste management. Now, from Ronald, and Ronald is really speaking to the cost-benefit analysis for the multiple options that you've suggested countries could consider. So, Ed, is there some work that you've done related to cost benefit or the cost breakdown for some of the options, be it incineration with degrading the solid materials that remain, or autoclaving, or whatever it is that you've shared with us?
So we have been trying to collect data. Again, this project started with 9 countries back in 2021. And in fact, it was extremely exciting at ASLM Cape Town that a number of countries presented their data on what they were doing, looking at costing. So it has taken a little bit of time for us to receive that information. I've not organized it into a document of these are all the costs. However, Francis, what I tended to do with the previous presentation I'd done for ASLM, I answer all the questions and I provide it back to you. So I would say to Ronald, let me answer the question with the data that I have available and the references I can point to, because it's an evolving story that we are looking at local, in some cases, example in Nigeria, they were looking at collection in one particular facility using large plastic containers for large volumes of liquid, 1,000 liters for it to be disposed of. We have the data from Juba. Would like to get a little bit more into that on costing. So this is a active investigation. And we're getting, if I could be quite honest, it's like pulling teeth to get information from some of our colleagues. I know that they're busy. So we have some, I will organize this into my replies to the questions, and we can share it with the attendees once I get it back to you. Is that good?
Thank you. Thank you. Thank you very much, Ed. Yes, very good. And because there are quite many questions and we probably won't deal with all here. And so we'll again put together all the questions and make them available to you so that then we can have a documented response. And that will form part of the documents that we'll be sharing with all participants who are with us today. Let me allow you to take a breather and I go to Rumbi. Rumbi, a small, quick one from Ariet, and Ariet is asking, is the bulletin available to all labs that are using your product? Or decomposing the question, where can we get the bulletin?
So we will upload it because we recently updated it, but we'll upload it on our website. So that's the first part where you can get it. You can also get it together with this webinar. I think I inquired with ASLM. They will upload it together with this session. So please visit the ASLM website and you will see the bulletin uploaded as well.
Thank you. Thank you very much. Let me get to Ed or Victor. Ed, you will choose whether you go for this or Victor will deal with it. But Doris is asking, and she starts by saying that most of the waste that are generated from HIV viral load testing in our labs normally or partially contain GTC. So she is concerned and she wants to know whether this chemical affects water body. I hope that this question is not then meaning that for this particular lab or country, probably they're disposing or discharging their waste into the water. But that's just my hope. But Victor, what's your comment on this, or Ed, depending on who can take this?
Victor, can I answer this? I'll tell you why. Because while I had a little break and I saw this question, I did pull up a couple of references. So here's an interesting perspective. So cyanide and thiocyanate is going to be found throughout Africa, but the main source of that is not coming from viral load testing. It is coming from the mining industry. All right. You have tailing ponds that have thousands and thousands of liters of this liquid, and it is toxic to fish. Consider, though, when you're dealing with thousands and thousands of liters, that this is going to have an impact if rivers are contaminated. Now, what's interesting about thiocyanate as well as cyanide, it is degraded by ultraviolet radiation. So to a certain extent, it being diluted and entering into an open body source, that there is the potential. I say the potential because the two articles, one article I pulled up is discussing laboratory scale use of ultraviolet radiation. We actually know of a company already in Germany that makes a product that can actually degrade thiocyanate. So it's available on the marketplace. But this is when you're dealing with large volumes of liquid. There is ecotoxicity data as well in the literature that talks about, in fact, using fish as a marker for cyanide contamination of water. Part of that comes back to illegal mining. Okay, so does thiocyanate pose a threat to the environment? Yes, it does. The issue is, what's the concentration? Where is it being diluted, or where is it being discharged? This is why, again, we don't advocate, and we've moved away from any discussions on discharging to sewers, to sinks. But the reality is, we know that still happens. And if you're going to do that, I mean, the recurring picture that we saw was a container of liquid poured down a sink, followed by water. No, you really need to be diluting that liquid if you're going to continue doing that. That's why we provided this guidance to look at some of these alternatives. And I will post those references in my replies, Francis.
Thank you. Thank you very much, Ed. Let me get to Rumbi with this quick one. And Rumbi, there is a question still related to reverse logistics. And from the CFID side, from your perspective at CFID, is this something that is being considered, especially for facilities that may not have facilities to handle the safe disposal of spent cartridges?
Thanks for that. That has been raised by other countries, and it's something that we try and work around with countries, country by country. But as of now, we do not have any facility that handles that. It's still things that are being suggested by countries, but we have not actually implemented any of that sort.
Okay.
So it's still something that has been discussed and that is coming up, and we have not found a proper way forward with that.
Thank you. Thank you very much, Rumbi. And Ronald Kunga. And Ronald is asking, this might go to either Ed or Victor, depending. And so he's saying there are concerns related to environmental effect of some of the proposed methods of disposal. And so whether it be it incineration, be it autoclaving, burying, burning, whichever option that we've dealt with here and or are being dealt with out there, what are some of the environmental considerations that should be taken care of before choosing which method to use?
You know, Francis, can you unmute Victor, because he cannot reply? So Victor, I'll pass this over to you, if you can see him.
Kindly unmute Victor. Sorry, we didn't identify Victor early. And Fitsam, kindly, if you can, allow Victor to be able to unmute.
Hello, can you hear me, Francis? Yes, I believe that
Yes.
you can. Environmental concerns. Look, I have a different twist on this one. The initial problem with the GTC was that it is emitting cyanide gas when it is mixed with bleach. That was the first and primary concern. Of course, that releasing the, as Ed pointed out, releasing of the GTC into the environment directly untreated will cause harm. Now, each and every technology has its own good and bad parts. Each and every technology can be used for treatment of the waste, but in essence, you need a technology which really can reduce the risk from the waste itself. For example, autoclave sterilization cannot reduce the chemical risk. It can dilute the chemical contents of the ingredient, but it is not going to reduce the chemical risk. It is designed to treat the infectious waste. On the other hand, Ed pointed out that when we were testing this incineration of cartridges, the key component here is to look at the material, get familiar with your waste, know what is it consisted of. Because this type of plastic, the polycarbonate, does not contain chlorine inside. So once it burns out, it emits less harmful materials. It does not emit chlorine. And if it is burning on the safe temperatures above 800, if it is fed properly, it will emit less, or even if the incinerator is designed and equipped with the emission control parts. So in essence, the point of treating of the waste is to reduce the harmfulness of the waste, the hazardous level of the waste toward the human health primarily, and secondarily toward the environmental health. So this is how you should look at each and every technology. And for whatever we have been doing with the GTC liquid, for the treatment of the GTC liquid waste, we were actually trying to hold on to and to prevent the emission from the treated waste into the environment by introducing all of these different combinations or treatment methodologies. Ed, you want to add something on this one?
I'm also going to take a slightly different spin, but this is partially related to we were given a mandate to find a solution, and no holes barred. We looked everywhere. And I'll tell you an interesting twist out of this that I think everybody in the African continent should be able to relate to. I suspect many of you eat cassava, correct? Am I right, Francis?
Yes, I do a lot.
And you know, there's a sweet cassava and a wild cultivar, and it has cyanide in it. So you have to properly prepare it. I actually just pulled up an article from the CDC of exposures and deaths in Uganda. It was reported in 2017. And what went through our head is, to reduce the cyanide, you have to dry it, you soak it in water, you have to cook it. We actually even found an entire text on this from the 70s. So we thought, why not? What if we cook the GTC, the Xpert cartridges, in an autoclave? I know Uta raised the question, our colleague from WHO, the gases. Not something we addressed, Uta. It's a great question. However, we're not releasing hydrogen cyanide gas. We had thiocyanate, guanidine thiocyanate. So there are questions out there of looking at, look, at the end of the day, or I should say at the beginning of the day, and everybody who's involved with biosafety knows this, eliminate the hazard. That would be step one. If you can't eliminate it, we substitute it. And if we can't substitute it, we start putting in different types of controls. So those are the things I think we should be asking industry to do, okay? And if industry can't help us, then industry maybe has to design something that is easier to dispose of, okay? We're just at the beginning of this journey. You know, that's what we start off saying in 2021. Let the journey begin. Well, we're still going along. Africa is a big continent, and there's a lot of roads to be seen. So let me end there. That's my thoughts.
Thank you very much. And on that note, I will ask Rumbi. I know that you've started doing the substitution that Ed has spoken about. Now, are you moving in the direction as CFID to get most of your cartridges GTC free? And you will also make your closing remarks as you do the answering of that question in about 30 seconds.
Okay, like I said, Xpert is committed to working with our customers, with partners, to make sure that the waste that is generated from using the GeneXpert is properly disposed of. There are things that are happening in the background, like I mentioned, and we will be uploading on our website. Some of the materials are already in the public domain, but feel free to visit our website and check what is available. But we are indeed committed to working and improving this burden that we all have. And thank you, everyone, for attending.
Thank you. Thank you very much, Rumbi. Ed, in 30 seconds, your parting remarks. Are you muted?
Am I muted now?
You're okay. You're unmuted.
Okay.
Please go.
Hit a button. Ladies and gentlemen, there's much work to do. However, we have made incredible progress by the cookbook, by our communications. This is an excellent platform. If I was going to say anything, if you do anything, share your results. Yeah. You have colleagues in Africa that need to hear from Africans. Yes, we're doing stuff in the US. Yes, things are going on in Europe, but what is going on in Africa? Things in Juba that have happened are great. In Windhoek, in Abuja, in Kampala. They want to hear those stories, and that's where you're going to learn and share experiences. And we have some people on our technical working group that really can discuss things in the context of Africa, as well as we have a member from the Caribbean. So even in the island nations, we're trying to address these issues as well. Thank you very much as well. Rumbi, thank you. It's great to be part of this. Francis, thank you, everybody.
Thank you. Thank you very much. And colleagues, time waits for no man. You can't imagine that we've spent 1 hour and 3 minutes already. It feels like we've just taken about 15 minutes. And as we come to the end of this session, I will ask that you hold it there. Don't go away yet, because we'll ask you to activate your cameras and we take some screenshots. But also I want to re-echo my earlier communication for those that had not yet joined, that in the next few, in just about a few sessions coming up, will be giving you or making available to you your CPD points, accredited CPD points. And for that to happen, you will have to attend about 45 minutes of every session. And then you will also have to request or apply for your CPD points through the links that we'll always be sharing on our chat when we're running a session. And then your CPD points will be available to you within 5 to 7 days. But do not forget that because we want to link this to you as an individual, we are asking you to please come with your registration number or licensing number. We could not ask you to do that today because I know even mine, I don't know it offhand. And so begin looking up your registration or licensing number so that when we are providing the CPD points, you will have it linked to your registration number so that if you're Chen Francis in one location and there is another Chen Francis, we do not confuse the two. With those, let's bring it to an end, but kindly activate your cameras, and my colleagues in the background will be taking a few screenshots for our records. FitSam, I hope you're ready for this, and we'll just take about a minute to get this done. Thank you again from us, ASLM. We are always very excited to have you join us and share this very critical information that we hope will help us improve lab services, both on the continent and beyond. So I just want to see the cameras buzzing so that FitSam can do the screenshots in the background, and I know he's already running them. So open your cameras, colleagues, so that we can take a few. Not everyone may be able to, but we'll do as much as we can. FitSam, you will confirm with me if you've run through all the screens. We have about 330 still available, and those might be about 3-4 screens, right?
Don't forget to smile, folks.
Exactly.
There we go.
And we will no longer forget to cook our cassava.
That's right. I have the recipes, by the way.
Thank you. Thank you very much, Ed. And FitSam, I hope you're good.
Yeah.
Okay. Thank you. Thank you very much, colleagues. And for those who may want to still run through the questions in the chat and some of the responses, we'll keep the platform open for about 5 more minutes, but we'll gather all the questions, make them available to Victor, Ed, and Rumbi, and then we will have those as part of the materials that will be made available to you. Thank you,
Francis. Thank you.
Thank you.
Perfect. Thank you.